Whenever I'm doing gas law problems, I like to write down the information from the problem in a sort of chart. So for this problem, a sample of gas at 15 degrees Celsius and 1 atmosphere has a volume of 2.58 liters. All of that's sort of my initial information, so I'm going to label those with a 1. So my T1, my first temperature, is 15 degrees Celsius. My first pressure is 1 atmosphere. I don't know why I'm getting these little skips. And then my first volume, V1, is 2.58 liters. And then all of this stuff is going to change during the problem, right? That's what happens in gas laws. You have some initial conditions and then some second conditions. So all of these are going to change. So I'm going to need a T2, a P2, and a V2. I like to keep them in the same order. So T2 is 38 degrees Celsius. P2 isn't really a P2. It stays at 1 atmosphere. And V2 is what we're solving for. What volume will this gas now occupy? Whenever I have temperature, so I have T2 and T1 here, whenever I have a temperature, I immediately convert to Kelvin. So remember that the Kelvin temperature is equal to degrees Celsius plus 273. So my 15 degrees Celsius becomes 288 Kelvin, and my 38 degrees Celsius becomes 311 Kelvin. So that's the first thing I do, convert my temperatures. Okay, so we can see here that the pressures didn't really change. And we're not really interested in those. Those are constant. So there's no change in pressure. That means there's going to be no change in volume as a result of the pressure. The only change in volume that occurs is going to be because of the temperature. So we're really dealing with Charles' law. So V1 over T1 equals V2 over T2. So now I can just plug my information in. V1, 2.58 liters over T1, 288 Kelvin. And that's equal to V2, this is what we're solving for, divided by T2, 311 Kelvin. So I'm just going to cross multiply or multiply both sides by 311 Kelvin. Don't have quite enough room over here. Stick the little K up there, right? So the 311 Kelvins cancel over here, and I'm left with just V2. On the left-hand side, the Kelvin units cancel, and I'm left with just liters. So V2 is equal to 2.79 liters. It's always a nice idea at the end to think about whether your answer makes sense. So our temperature increased, and that should have resulted in a volume increase. Well, it did. We went from 2.58 liters to 2.79 liters.